Okay, here we are on page 7 and 8 of differentiation. On this page, we're going to do some word problems. The problems are going to be just as easy as the ones you've been doing. It's just that sometimes they're going to give you different words for finding the derivative. Sometimes they're going to say that they want to find the gradient of the curve or the equation. So, number one. Point P lies on the curve y equals x squared plus 3x minus 4. The gradient of the curve at P is equal to 7. So they actually know the gradient of the curve at a certain point P. Find the gradient function of the curve. Okay, so find the gradient function of the curve. That just says find the derivative of the curve, and you know how to do that. So you're finding the derivative of that. You could write y prime, or you could write dy dx, whichever you like. And you could write that the gradient of the x squared function is just 2x. The gradient of the 3x function is just 3. And the gradient of the negative 4 is just 0, so you don't even need to write 0. You just write 2x plus 3. That would be the gradient function. Find the x-coordinate of P. Okay, so what we know about P is that at P, the gradient is 7. So actually, the gradient is, you remember, the derivative. So we know that at y, that y prime is 7, that x-coordinate is going to be P. So if we could find this x here, that would be the x-coordinate of P. Okay, then we'll worry about, first, see, we just find the y-coordinate. So we know that the gradient is 7. When is the gradient 7? Well, the gradient is 7 when this equation is satisfied. How do we find x here? We use a little bit of algebra. Subtract 3 from both sides. We get 4 equals 2x. So we know that x is equal to 2. Okay, so that's the answer to B. And C, it asks, what's the y-coordinate? The y-coordinate, now don't just take the 2 and plug it back into this equation. Don't plug it back into the derivative equation, because that is just going to give you the gradient. So what you want to do is you want to put it into this equation, the original equation. If you put it in the original equation, that will give you the y-coordinate of point P. So you put it into y equals x squared, so that would be 2 squared plus 3 times 2 minus 4. So that would give you 4 plus 6 minus 4, which is just 6. So point P is actually the point 2, 6. Okay? If you want to check that, you could even do that on your calculator. You could put this equation in your calculator, and then you could find the derivative at point x equals 2, and you could see if you get 7 back. Okay. All right, number 3. Point R lies on the curve y equals 4 plus 3x minus x squared, and the gradient of the curve at R is equal to negative 3. So let's see. Let's find the gradient function of the curve. They're really nice to you, and they tell you step by step what you need to do to find R. So it will be y prime equals, and the derivative of 4 is 0. The derivative of 3x is 3. The derivative of minus x squared would be minus 2x. So the gradient function is this, or the derivative is this. Now, they want to know when the gradient is negative 3. So when is y prime negative 3? Well, what x makes that true? Let's subtract 3 from both sides. We'll get negative 6 equals negative 2x. Then we divide both sides by negative 2, and we get x equals 3, which is negative 6 divided by negative 2 is 3. So we know that the x-coordinate of point R is 3. What is the y-coordinate of point R? Well, all we do is we take the x and we plug it back into the original equation to find the y-coordinate of R, because R is on the curve with the original function, so all we need to do is put 3 back in for x, and then we can figure it out. So that would be 4 plus 9 minus 9, so that's just equal to 4. So the coordinates of R are 3, 4. Okay, number 5. find the coordinates of the point on the curve, y equals 3x squared plus x minus 5, at which the gradient of the curve is 4. Okay. Now I'm gonna, we've done it analytically a couple times. Let's do it with the calculator, because you can also do it with the calculator. They give you the function, so the first thing you're going to want to do is you want to type the function into the calculator. So it's 3x squared plus x minus 5. Okay, and then we are going to graph it. Okay, and then let's see. We are going to find the point where the gradient of the curve is 4. So let's see. Let's try. Let's see. We'll do second calc dy dx. And then